Problem 823. So a person is pulling down on a paper towel dispenser with two rolls, and then the bottom roll is pinned at this point, we'll call it A, and it's free to spin. And then the friction here will cause the top one to spin. Well, it could slip at D, but because the coefficient of friction at D is 0.5 and the coefficient of friction at C is 0.2, we're going to assume that it sticks at D and spins and slips at C. And then we'll check to make sure that happens. Because if you have a normal and a friction, you can use mu times the normal and get the friction if it's slipping. If it's sticking here, you may not be using all of the friction, so the friction there still has to be an unknown. So we're going to go with sticking here and slipping there, and ND and FC are both their own unknowns. So let's draw a free body diagram of A. I'm going to put that point A in the middle. And down we have MG. And there is a horizontal A at X. There's a vertical A at Y. And then we have a friction. As it spins this way, it pushes this roll this way when this roll is pushing back. So the force of friction at D is going that way, and ND is going down towards roll. So let's start by summing the moments about A. If we sum the moments about A, MG doesn't matter, AX doesn't matter, AY doesn't matter, and ND doesn't matter. Oops, I forgot P down. So all we have is P causing positive rotation times the radius, 3 inches, and we have minus FD times 3 causing negative rotation, and that equals 0. So P equals FD. And that's all we're going to need from that lower roll, because they're not asking for the reactions, they just want to know what P is. So we'll take that P and go up and use this bigger roll, and call the center point D or B. It's got MG down. It's got a force of friction equal and opposite. So we got FD here, and we got a normal there, equal and opposite. And right here, as the roll spins this way, the friction pushes back. We'll call that FC. And the normal goes there in C. So looking at the bigger roll then, we'll start by summing the moments about D, or B. If we sum the moments about B, we have NC doesn't matter, ND doesn't matter, MG doesn't matter. All that counts is FC and FD. So FC times 4, and that's positive rotation, minus FD times 4 equals 0. So FC equals FD, which equals P. Let's sum the forces in the x direction. So in the x direction, ND and FD and FC and NC will all have components in the x direction. Looking back here, we got a 45-degree angle here. So everything going in here is going to be 0.707. And then over here, we got a 60-degree angle right there. So if that's 60, that's 30. And let's draw this one up this way. And that angle right there is also 30. So summing the forces in the x direction, we have FC sine 30. And we have NC cosine 30. Minus FD, or 0.707 FD, and minus 0.707 ND. And that all equals 0. So we can solve for sine and cosine, which equals 0.5 and 0.866. We can put P in for FD, and this solves down to negative 0.207P plus 0.866 NC minus 0.707 ND equals 0. Now let's solve for the forces in the y direction. We'll keep underlining that equation. We're going to come back to that. So in the y direction, we've got positive, or FC is negative C, and that time it's cosine 30, plus 0.5, or I guess it's, I'm skipping a step there, NC sine 30 minus 0.707 FD. So FD is going down, and then ND is plus, so plus 0.707 ND. And we have mg going down, which is 5. Now let's combine. So if we use FC and FD equals P, we can put P in there. We can put the cosine of 30 is 0.866. The sine of 30 is 0.5, and FD is also P. And so we can combine all this into 0 is equal to negative 1.57 P plus 0.5 NC plus 0.707 ND minus 5. Now, if slipping occurs at C, we can say that 2.2, the coefficient of friction at C, times NC is equal to FC, which is equal to P. So P is equal to, or NC is equal to 5P, dividing both sides by 0.2. So if we put that into this equation, NC is 5P, then we get 5P times let's put it into this equation. So we put it in right there and combine those two, and we get 0 is equal to 4.123P minus 0.707 ND. And out of that we can find, moving this other side and dividing by 0.707, ND equals 5.83P. Now we can put that, moving this equation down, we put that in for ND, and I'm going to move 5 to the other side because it's negative, so 5 is equal to negative 1.57P plus 0.5 and NC is 5p, and plus 0.707 ND, and ND is 5.83p. So if you multiply 0.707 times 5.3 and add 2.5p and then subtract off 1.57, we get 5 is equal to 5.05 d, and or p, sorry, and p is equal to 0.99, which is the answer. Now, as a check, we can say p is equal to FD. So FD is 0.99. Now our FD max is equal to 0.5 ND. And ND was 5.83p, which is 0.99, so it's pretty much 5.83. And then, so we could say 5.8 is equal to 0.5. Where was I? FD max. Okay, never mind. So FD max is equal to 0.5 times 5.8. So that's equal to 2.9. And that's higher than 0.99, so slipping does not occur. Slipping does not occur at D.